Here we are going to discuss the important points of number theory, and in this lecture series we will try to understand the basics of number theory by using some examples and also by solving the various problems at very basic level. So now here you can see we are just discussing the sum of squares and the number shapes. In first point, the sum of a square, which number are sum of two squares? It often turns out that question of this sort are easier to answer first for primes. So we ask which odd prime numbers are a sum of two squares. For example, 3, this is not the sum of two squares. 5, yes, this is the sum of two squares. 1 and 2 are the digits involving here. 1 square plus 2 square equals 5. Same here. 7, so there is no the sum of squares of digits or numbers. Same here. 11, the answer is no. But here 13, there is a possibility for 2 square and 3 square, so 2 square plus 3 square is equal to 13. Same for 17, 1 square plus 4 square is equal to 17. For 19, there is no, and for 23 there is no. For 29 is equal to 2 square plus 5 square, so 29 can be written as a sum of a square of two numbers as 2 and 5. For 31 it's no. For 37 this is equal to 1 square plus 6 square, and so on. There are many numbers. We can simply identify those numbers. So here do you see a pattern? Possibly not, because this is only a short list, but a longer list leads to the conjecture that P is a sum of two squares if it is congruent to 1 modulo 4. In other words, P is a sum of two squares if it leaves a remainder of 1 when divided by 4, and it is not a sum of two squares if it leaves a remainder of 3. This is important statement. You should note down that the P is a sum of two squares if it leaves a remainder 1 when divided by 4, and it is not a sum of two squares if it leaves a remainder of 3. Like here you can see, when 5 is divided by 4, the remainder is 1. Same here, when 13 is divided by 4, the remainder is 1. Same here, 17 is divided by 4, the remainder is 1. Same, 29 when divided by 4 gives the remainder 1. So this is very important statement, that in other words, P is a sum of two squares if it leaves a remainder 1 when divided by 4, and also in terms of the congruent and modulo, simply P is a sum of two squares if it is congruent to 1 modulo 4. In the chapter of modulo arithmetic, we have already done this thing, like A is congruent to B mod n, where n divides A gives remainder B, or n divides A minus B. In the number shapes, the square numbers are the numbers like 1, 4, 9, 16 that can be arranged in the shape of a square. The triangular numbers are the numbers like 1, 3, 6, 10 that can be arranged in the shape of triangle. The first few triangular numbers and square numbers are illustrated in figure 1.1. Actually, while we were discussing the topic of algebra in the section of number system, we have already done the triangular number, the square number, the pentagon number, the hexagon number, octagon number, and so on. So here is the just for recall that here 1 plus 2 equals 3, same 1 plus 2 plus 3 equals 6, same here 1 plus 2 plus 3 plus 4 equals 10. These numbers are called the triangular numbers like 3, 6, 10, etc. Same here, the square of 2 is 4, the square of 3 is 9, the square of 4 is 16. These are called the square numbers.